So in my time, I'm a video engineer at CoreOS. Since I'm from engineering or from marketing and product management, my slides are gonna suck, so just prepare you guys. But feel free to ask me any questions. I'm actually more or less prepared. Not as good as some of the engineers on our team, but I'm pretty prepared to answer technical questions. Right? So I'll talk a little bit about Kubernetes and Tectonic and CoreOS. So this is a little bit about us, right? So we're a startup in San Francisco. Our headquarters are in San Francisco. We also have an office in New York, which is great. Our registry, I talked about it. And we also have an office in Berlin, engineering office in Berlin. We have a lot of famous investors, including Intel. Our team mostly came from various Western providers, and we are trying to address the pain which we experienced in some shape or form in the past. I have engineering background and DevOps background, so what we do relates a lot to me and my pain in the past running DevOps and Ops teams and development teams and so on. So this is a list of some of our customers. It's not a complete list of others. Just to show you where we're in. How many of you have seen slide like that before? So you guys attended some conference about containers, right? So I don't know how people use this, but it's just kind of an indication for me how many people are aware about containers and so on. How many of you heard or used looked at Kubernetes before? Or heard Kelsey talking about Hideout? So I'm not going to repeat his speech about Kubernetes is great and so on and so forth. But I'll do kind of a quick, short recap. So Kubernetes, right, obviously came out of Google originally. Craig McClinky, one of product managers at Google, convinced the management that the most secret project at Google board, which I have a friend who actually worked on board before Kubernetes was announced. He could not talk to me about board, right? So that's how secret it was inside Google. Google considered it the premier advantage, competitive advantage. And then he convinced the management we have to open source it, right? And Google actually agreed. So Kubernetes came out of work in Omega. It was open sourced in July 2015. The first release went out. And it's a platform kind of high level. I know that I said repeat all the stuff from Kubernetes. High level, we can think about it as a set of APIs to make a data center essentially virtual, right? Any data center. I'll talk a little bit about it, right? And it started at container-based development. The developers, as a result of their they produce is not a J2EE, not a jar file, or file, or executable file. The artifact as a container. You just throw those containers to Kubernetes, and somehow magically they'll run. How popular is Kubernetes, right? So this is the research. There is not enough research. It's actually a relatively new product. I know Gartner is working on kind of more official report. But there was also a user survey which indicated which container tools used to manage website applications. Kubernetes by far was the most popular one. Even though on this list is the youngest. And in terms of development engagement, earlier analysts for Red Month, they measure development engagement based on meetups, GitHub, blogs, and various metrics. And the development engagement, this not easy to see rate for Kubernetes is actually exponential. And why is it important? Because in the end, right, in the modern world, it's developers matter, right? Developers are hard to find. They're hard to retain. If they want to use containers, it's very hard for anyone to go against the development team and say don't use containers. So it's a development world. So what's Tectonic if anything after this, you can walk out of my presentation if I'm too boring. So Tectonic is basically an enterprise distribution of Kubernetes, right? Think of it as if Kubernetes is Linux kernel and Red Hat Enterprise is a distribution, commercial supported distribution. The same about Tectonic. We totally rely on upstream distribution. We build everything around upstream. Distribution you can download from GitHub. We don't change a single line of code. We don't carry any patches. We actually We are not the largest contributor to Kubernetes, Google is, and Red Hat is ahead of us a little bit. But if you think the size of the companies, they're about 5 people company at this point, in terms of amount of engineers percentage-wise, we commit to Kubernetes, we are by far the largest, right? Kind of more than half of my engineering team is committed to work in the upstream. And we make very hard to make sure the voices of our enterprise customers are heard and converted to actual upstream code, which is open source, right? So what we have, our expertise for a lot of people and kind of how CoreOS started was around security. So we want to make sure that Kubernetes is secure. And we want to make sure it's secure in upstream distribution too. But certain things kind of only in our enterprise distro. It's also we want to make sure that it's multi-environment, right? So you can run. So obviously Google is interested in JKE, right? So if Google Container Cloud, right? So if you want to use JKE, run the same version of Kubernetes. So they're very honest about that, right? If you want to use Google Cloud, you go to Google there, right? We kind of want to make sure everywhere outside of JKE, you can use Kubernetes exactly the same. And that's part of the Google Ventures investment tool, right? We can share this vision. So the traditional enterprise, right? I think there are a lot of talks here about this, right? Traditionally, it's all silent. You build the silent around peer-to-peer, around HCM, around big data, platform as a service, such as OpenStack Cloud Foundry, or potential infrastructure as a service. You can argue those in terms. Actually, I came to CoreOS from a company called MuleSoft, which does a lot of integration because of this world. It's a very quickly growing company, doubling revenue every year because all the things need to somehow get integrated together, right? It's a very painful problem with the enterprise, right? And part of it is lack of flexibility, low utilization. You probably heard it many times by now. So how is the kind of modern enterprise different, right? More and more companies converge into putting applications in containers. We have customers who have 20-year-old applications from which they actually lost the source code, believe it or not, it came out as a part of acquisition. They're able to run this application as a container, right? So whenever you hear that containers cannot do something, it's not always trivial, don't get me wrong. But we have an example of it's a very, very old binary run this container, right? So it's possible to containerize almost everything these days, right? Including storage. Again, storage is the kind of last mile in this world. It's not trivial. There are implications around networking or high throughput applications. All of it is solvable even with containers, right? It's an event run any application, it's an event run commodity hardware, right? Use application containers for many reasons. Part of it is configuration management, ability to test, dynamic scheduling. What Kubernetes and by nature with Tectonic bring is automated scaling, resilience, self-healing, and dynamic scheduling, right? And why all of those important? And why it came out at Google, right? Google realized very early on they have so-called SRE model, right? Software reliability engineers. You can have very limited amount of ops people. You can have a lot of developers, right? If you start growing the amount of ops people, actually you cannot maintain infrastructure at some point, right? There's just too many efficiencies, they clash together. Even with modern configuration management tools, it's painful, right? So they decided to, since they have a lot of developers and a lot of expertise, why don't they write software which actually self-manages operating center, right? And the model became SREs maintain the software, originally Borg, now Kubernetes, and your development teams actually self-serve, right? Once they build the container through the continuous integration, they serve the containers as the infrastructure, and it's their problem to operate these containers, right? And a lot of abstractions are taken away from them, a lot of errors taken away from them. The system is able to, if containers run out of memory, kill and restart them automatically. It's not the ideal scenario, but helps you as ESLs, right? And Google pioneered it about 15 years ago to work, right? And it worked, right? Living proof of it. And I think currently more and more enterprises are starting to get into the same realm as Google, not necessarily based on the amount of traffic, but based on reality that a lot of large enterprises are this monster creatures of acquisitions, with multiple teams working across multiple continents. They use all kinds of technologies, all kind of applications, all kind of data centers, cloud, not cloud, hyper-converge for them is just daily reality, right? And the technologies that Google originally built kind of, and they don't have enough ops people. Like if you work in any Fortune 500, you probably know it. It's very, very hard to get ops people. It's hard to find contractors to do ops, right? So they just don't have enough ops people. So finally, almost every large enterprise these days is like mini Google in a sense, right? You have a lot of infrastructure, it's all disjoint, came out as part of acquisition, a lot of developers, not enough ops people, and pretty much any modern enterprise has kind of at least 800 applications, so critically important business applications according to Jarvis these days, right? So downtime is not an option. So where Tectonic comes from, right? So, and kind of an addition to upstream Kubernetes, which you can install in any environment, you just don't support it on your own, right? It's open source. We provide support and ability to install it on most of the public clouds, as well as bare metal OpenStack virtual machines, right? But the idea behind it, there's a need of enterprise again, right? You have a startup, SAP is an example, right? It was a startup, companies which run on top of AWS. It has a huge data center, it has VMware, right? They have some presence on Azure, right? How do we abstract all of it so that developers don't have to care where they deploy, right? That's where Kubernetes comes in and take the investment. So what's a Tectonic exactly, right? So we started as a company from CoreOS Linux, and how many of you are familiar with CoreOS Linux? So it's also an idea which actually came out of Google, right? If you have a data center, large data center, and you're relatively famous, you're constantly being attacked, right? At the moment, vulnerability in Linux kernel found, and then there's one found pretty much every couple of days, right? Some of my competitors in Russia, for example, create a bot which scans the whole world for this compatibility, vulnerability, and tries to perform an attack, right? On the other side, it's not true. All data center updates traditionally are manual, right? So while the attackers are automated, data centers not. So CoreOS and Linux solve this problem, and Google has similar distribution behind the scenes, right? Where whenever CVEs come out, we update our distribution. We have a number of channels, alpha-beta tables. So all the channels updated weekly with all the vulnerabilities in the kernel. We're always the first one out of open source Linux distros to provide patching all vulnerabilities. We have a service, public service free, which we call CoreUpdate, which pushes to all the CoreOS machines out of the update. CoreOS has immutable user and root positions, and it has two of them, so the new update is always applied, machine is bounced. The idea kind of right behind the machines are also in the cluster. We can cluster CoreOS Linux boxes, and we usually have a certain amount of logic how we reboot not the whole cluster. So we reboot it gradually, so you don't have any downtime. On top of it, so CoreOS natively supports two container runtimes. One is Docker, one is Rocket. Rocket is our container runtime. I'm not going to dive too much into it. If you have any questions, ask me after it. So both of them are supposed to be OCI compatible runtimes. In the future, we will support more runtimes as they come out. HCI is key-value store, which is used, distributed key-value store, which is used Kubernetes by storage. It's a product that CoreOS originally created to provide support as part of Tectonic for it. There is support for Canal, which is funnel plus security from Tigera. Obviously Kubernetes, and the parts we add is trusted computing, identity management, which is required in enterprise world. Monitoring and logging using Prometheus, another one of our open source projects, and the management console. The ideal management console, I'll demo quickly, is to give developers self-service. Right? They can see what's happening with the applications, deploy easily and so on. They don't have to worry about all the infrastructure and lines and so on. We also have the registry Play, which kind of similar alternative to Docker Hub with a lot of enterprising features. If you're on containers, you have to start with somewhere. So it's basically a full solution, kind of which mimics what Google has internally, so which you can install in your data center, you can deploy it on AWS, and have the same infrastructure commercially supported by CoreOS. What's distributed trusted computing? So how many of you are familiar with what TPM is? So TPM is obviously a module and a motherboard which allows you to generate unique hash. We extended the idea kind of all the way from firmware to Kubernetes cluster. So you have to use CoreOS Linux and you have to use Rocket because not all Linux distros and kernels provide support for TPM, and Docker right now doesn't support TPM version of container level. But basically the idea is you extend end-to-end cryptographic chain of trust. So if you ship your app to the countries of trust, for example, right, you can set it out from the get-go that if it's kind of was tampered in any shape or form. If somebody deploys containers with the image you're not supposed to deploy, so the Kubernetes cluster can mark this no disdain that it denies the deployment. Rocket is a runtime, a container runtime. It can run Docker images out of the box. It's fully Docker compatible. It can run new open container initiative images, which is essentially Docker 2.2, and HCI images, which is the original Rocket format. It's kind of, you can look online the number of videos and documentation explaining how Rocket is different from Docker. We are not targeting kind of Docker is very, very good to give them credits they totally deserve around developer toolchain, right? Create the images, run kind of packaging the images, configuring the images, build them. Rocket is just a runtime system. There's some minimalistic build tools, but mostly it's a runtime. It's a very different philosophy, right? Kubernetes introduced something called container runtime interface, and it's coming out in Alpha 1.5. Rocket will support it kind of in 1.5 release out of the box. The idea behind it is that Kubernetes wants to abstract container runtime completely. You can pick whatever runtime you want. LKVM-based container runtimes and so on, right? So the idea is that no matter what container runtime you're going to use, if it's, let's say, compatible, you can choose one runtime. And we are part of this effort. We will provide project reservations implementation. The other interesting thing is people who are migrating from containers. Rocket supports LKVM output is one of the options for runtime. It supports C groups and namespaces similar to Docker, but it supports LKVM. And it's an interesting option for people who want KVM-based isolation, but runs for container environment. So I talked a little bit about CoreOS Linux before, right? This is kind of core update, the server side. You can buy the software which you run in your data centers. You don't need to use the public update side. And the idea is kind of, right, to continuously patch your Linux distro for security as part of the cluster. Quay is an image registry. It's fully compatible with Docker format. What it provides an initial to Docker Hub is bunch of enterprise features. This is the only non-open source product we have today. So it provides HA, geographic distribution, continuous garbage collection, so that your old images get garbage collected and removed. And a lot of integration. Integration is held out and other identity management systems for enterprise usage. It also provides Claire, which is our open source security tool, which continuously scans containers for security. So if for example, your base image has a known vulnerability, it will be flagged. You can see kind of this is the example of vulnerability scanning UI, right? And you can also disable, you can define well of DEFCON 1, basically disable ability for developers to use containers which is secure. Claire is open source and fully extensible. You can write your own security checkers to use public databases with CVEs, but if you can have a Java application, particular jar shouldn't be part of the image, you can extend Claire to the and this is Tectonic management console. It's, to some degree, it's kind of mimicking GIFEE console, right? The same idea, right? Developers should be able, without going to command line, deploy their applications, create their own dev, QA, test environments, all the way to production, like troubleshoot what's happening with their apps, completely self-service model for developers. This is the example kind of, right? There's faster web, Kubernetes logs a lot of things, and so Tectonic exposes these logs to development teams. We have a very fine-grained permission model, so as a reason, Tectonic administrators can define which business unit is which which groups of clusters, which nodes, what do they have access to. This is the slide sales makes it to present. What does it mean for your teams? Basically, it's better tools which are standard across the team, right? That helps your teams to get to market faster. So for developers, deploy faster, right? You don't have to worry about idiosyncrasies between various cloud providers, the APIs, what type of storage, what type of networking. It's all abstracted through Kubernetes cluster, right? There are examples of companies running, for example, their test infrastructure on AWS while their production is on bare metal. Traditionally, it's a painful exercise because we cannot guarantee that the environments are the same between AWS and bare metal, but because Kubernetes fully abstracts it away, you have a guarantee that it's the same. For operations, it just simplifies life. Operations don't like patching, don't like fixing, they like writing code around to help developers be more productive. And Kubernetes gets that. So we are running Kubernetes in-house for our infrastructure, and our infra team mostly codes, extensions, tools around Kubernetes. Cube AWS, very popular open source tool for deploying Kubernetes on AWS, was written by our infrastructure. From security, I already talked to, right? So Tectonic extends Kubernetes to provide a zero trusted compute. You don't have to worry about patching your infrastructure. You don't have to worry about manually tending servers, right? It's all fully automated. And if you need to justify why you're paying all of money, yes, because you're going to bring the products to market faster, and also because the developers will be happier, right? They're working on cutting-edge technology. Nothing makes developers more happy than that. So where to get started, you often ask, right? If you're moving applications to cloud, very natural way to start there. If you're rebuilding some applications from scratch for whatever reason, that's the other target, right? New web applications, we highly encourage people to consider microservices and then Kubernetes and containers naturally. But I still have to see an application which does work. We took with some project by Intel and Mirantis. We took OpenStack at CoreOS and said, hey, OpenStack is just a Python application, right? How hard can it be? And we ported it to run on top of Kubernetes. It's an open source project called Tectonic, which we built together with Intel OpenStack team. It was originally down at OpenStack Austin Summit. There is a video on YouTube. At Barcelona, we will demonstrate fully production running OpenStack. And so, if application like OpenStack is all the storage layers, RabbitMQ, MariaDB, right, persistency, stateful applications, right, you can run on top of Kubernetes successfully. Operating means pretty much everything. Some of the quotes, right, Box is running Kubernetes in production. The CTNet co-founder says it resulted in reduction from 6 months to launch a service to less than 8. So, pretty amazing statistics. Look, they have pretty new infrastructure, right? They're relatively modern startup, right? If they can get that level of improvements, imagine how much an old enterprise is a lot more under the target. Achieve.